Let's now talk about potassium availability and potassium application to crops. So really taking a look at soil test results and how do you interpret these results to come up with a fertilizer recommendation for any crop here in Ohio and surrounding states. And so this is a fertilizer application, or I'm sorry, this is a soil test report from somewhere in Ohio from locations that I have no idea where they're from. There's a lot of information on this test report, but what I highlighted here was potassium. And this is actually extractable potassium in the exchangeable form. And really, it's actually exchangeable potassium concentration plus whatever potassium is in soil solution. This, or these numbers of potassium are in parts per million or milligrams per kilogram. And they are extracted with something called neutral ammonium acetate. It states up here. And it's exchangeable, which is stated inside the parentheses. Now, these numbers may not mean much to you, but usually when you provide a soil along with a crop that you want to grow on a particular parcel of ground and send that soil plus the crop to a testing lab, they'll come back and tell you what these numbers mean in terms of low, medium, high, very high. And that's what these values or letters represent here. In Ohio, ammonium acetate has been historically used. But people are switching to MELC3 extractable potassium, and there's a reason for this. The reason is the MELC3 extraction is a multi-element extraction. And you learned about MELC3 being used for extracting available phosphorus in the phosphorus unit. And so there is a push to move from ammonium acetate to MELC3. And there's been a lot of work in the state of Ohio to correlate the differences between ammonium acetate extractable potassium and MELC3 extractable potassium from soils. And to simply convert from these values in this column that are highlighted in red to, which are ammonium acetate values, to MELC3 values. A lot of work suggests that we multiply ammonium acetate by 1.14. So these are the values from the previous slide. And all I did was copy them into Excel, and then I multiplied this column by 1.14 to tell us what the MELC3 extractable potassium concentrations should be. And those concentrations range from 158 to 495 or 496. Yeah. Okay, so keep those concentrations in or at least the range in mind. So what we do is to come up with fertilizer recommendations for application rate of K2O, which is the application rate of potassium in the fertilizer form, and you'll learn about that later in this unit, expressed as K2O. We go to something now called the Tri-State Fertilizer Recommendations for corn, soybean, wheat, and alfalfa, Bulletin 964. And you can find this freely available online. It's recently published. We go to a table like this, which is corn potassium recommendations for Ohio and surrounding states. This is based on the corn yield potential in bushels per acre, okay, 150, 200, 250, and 300. The MELC3 extractable concentrations, which range from 158 to 496 parts per million, and the soil cation exchange capacity. So sandy textured soils versus finer textured soils, if you will. All right, and so this table in and of itself ties directly in with what you learned in the cation exchange capacity unit, right? And so the way this table works is you use your MELC3 potassium extraction values and go to a table like this. So you need to know something about cation exchange capacity and the extractable potassium concentrations from MELC3 extractions. And you go to a table. And so the lowest value in the range that we were looking at was 158 parts per million. If we had a coarse textured soil, we would not have to add any potassium to this soil. If we had a fine textured soil at the lowest range of 158, which would fall within this range on the table, depending on the corn yield, we would have to add either 50, 60, 70, or 80 pounds of K2O per acre. And that's how this table works. The table works based on, I'm not kidding, probably decades worth of research from soil scientists focused on soil fertility aspects within the environment to come up with these recommendations that you see in one single table. One important point to note about this table is that there is a difference between the upper portion of the table and the lower portion. Difference is based on soil texture, which is related to cation exchange capacity, which you've already learned in this class in terms of putting the soil fertility puzzle together. Clays and loams for fine textured soils require more potassium. Why? Because there are more exchange sites for potassium to be sorbed to, and there's likely less of the ability of potassium to be removed from all of these exchange sites, i.e. the buffer of potassium in the soil, for the plant to see the potassium. So the bottom half of the table always has greater values than the upper half for any given pellet-free potassium extraction number or range. And so this concept repeats on the next several slides. So here is the slide for soybean potassium recommendations in Ohio. And again, if we had 158 parts per million at the low end, we wouldn't need any potassium in coarse textured soils, and we would need some potassium in fine textured soils. The same holds true for wheat. Okay. 130 parts per million or greater, we don't need any potassium in coarse textured soils. And we are at the low end, 158 parts per million of potassium, and we would need some potassium for these finer textured soils. And I guess I should mention that we have quite a bit of potassium in some of our soils here in Ohio. I mean, the high end is 496 parts per million, so we're way off the chart. The last slide I want to show you from the tri-state fertilizer recommendations is for alfalfa. And the same thing holds true for alfalfa. We hardly need any potassium for these soils with a range of, or the low end range of 158 parts per million. And we probably need some potassium at those low ppm levels of potassium in the test for the finer texture soils. And last but not least, potassium in turf grass follows a different approach in Ohio. And that approach is based on the fact that we don't have a very good test recommendation for potassium here in Ohio. And so we have to look elsewhere for those test results. And so we look at either Purdue in Indiana, or we look at Pennsylvania. We specifically look at Penn State. So this is the recommendations from Purdue. The recommended annual potassium applications based on the soil test results. And here are the soil test results in this column. All right, parts per million of potassium, rough estimate of the level of potassium in that soil. And based on these test results that you would get from a testing lab, how much potassium you need to add in pounds of K2O per 1,000 square feet per year. So let's stop here with our discussion on how to apply potassium to systems.